Hey guys, Dr. J here, and we're going to talk today about how to collect the last bit of data that we'll need for our acceleration lab, okay? So before we do that, let's go ahead and take a look at the data that we already have. So here are our data from last time, and your data will look a little bit different from mine, probably. So we completed 3 measurement trials, okay? Low block, high block, and table. All right, and after we entered our data, we wound up with this table here, okay? So what we did was we collected data here, here, and here, and then those data allowed us to produce this table, and then this graph along with this mathematical relationship, okay? And your mathematical relationship will be a little bit different from mine, and that's fine. But we all got our own mathematical model that allows us to use the height at which a golf ball is released to predict the velocity, okay, that the final velocity that that golf ball will have once it has fallen from that height, okay? So pretty cool stuff that we've done so far. Now let's see how we're going to go ahead and extend from this point. All right, so in order to do this, we've got a new spreadsheet, okay? We've got a new spreadsheet. So here's our new spreadsheet, okay? And what's cool is we've actually already collected data here, okay? So this balcony trial was the trial that we did last time when we dropped our golf ball off the balcony, okay? So we've already collected these data. You can just go ahead and input your data here, here, and here, okay? From your notebook. And all of these times actually should be approximately equal to 1.0 seconds, okay? So you really want data that are between like 0.85 seconds and 1.15 seconds. If your data are significantly outside of that range, I would say recollect, okay? Recollect these data. And I'll allow you to take a golf ball and to go outside and do that. Just be safe and be expeditious. That means efficient with your time, okay? So we all should be getting data pretty close to this guy and within this range so that we can have accurate measurements and assessments of error later on. All right. So next order of business, we have 2 additional trials to complete, okay? Trial 4 and trial 5. So what are those, right? So this says above low block and above high block. Okay, so what does that mean, right? These are, so this trial over here, this balcony trial, this was an extrapolation. We're using these data to test our model's ability to extrapolate. So we collected this data for testing our model's ability to extrapolate. So this is for testing extrapolation. We'll be collecting that's all of this over here, okay? We'll be collecting these 2 data sets here, okay? These guys are for testing interpolation. Okay, so these data will tell us how well our model interpolates. So they'll allow us to answer this question: how well does our model allow us to interpolate? And then these data over here will answer basically the opposite question, right? So how well, and I'll just put some dots because it's the same language, does our model allow us to extrapolate? Okay, how well does our model allow us to extrapolate, our mathematical model? All right, so that's ultimately what we're going to be doing with those data. we'll talk about that data analysis next time, okay? Today, we're just focusing on data collection, and then you'll also have some time today to catch up on any missing assignments and to conference with me if you have work to make up, okay? So today's gonna be a light data collection day, and then we'll also have time to make up some work if we need to, all right? So that's all out of the way. So now let's talk about what these trials are, okay? So this trial over here, that's been completed. We're done, unless you need to recollect data, which is fine. You'll be able to do that pretty quickly. So let's talk about what we mean here. Trial 4, above low block, okay? So let's go ahead and take a look at our experimental apparatus for that. And I'll pause the recording so that we can do so. Okay, so here I am back in the lab, and your first trial last time was your low block trial. So you placed your apparatus like this, and you arranged your apparatus like this, and you put your little golf ball right here, and you measured the height of the golf ball, right? So most of us got a height that was around 8.5 centimeters, okay? 8.5 centimeters, right about there is what we got, okay? So now we want to do a trial that's a little bit higher than the low block, okay? We want our distance to be higher than the distance we got, than the initial height that we got. So if we got about 8.5 centimeters for our starting height, well, we want a height that's a little bit higher than that, but underneath this high block, okay? We don't want anything that's quite this high. So what we do is we just move our ramp backward a little bit, and now we're gonna have a new starting height, okay? So this starting height here, this is gonna be, oh, what does that say? That's about 11 centimeters, I guess. That looks like 11, yeah, 11 centimeters, maybe 11 point something. Okay, you'll measure more carefully than I'm measuring here. So this is gonna be roughly 11 and some odd centimeters. Now that's higher than 8.5. So this arrangement will allow us to test our model's ability to interpolate, okay? Because we're not using the same height we used before, but we're not using, you know, some crazy tall height, right? We're using an intermediate height, and this height is not a height that at which we've collected data before, okay? So this is called the above low block trial, and your height for this trial should be somewhere around 11 or 12 centimeters high. But remember, you're going to convert to meters, so it's going to be 0.11 or 0.12 centimeters high, roughly. Okay. Now the next, so that's for this above low block trial. Okay, so that tells you how to collect data for this above low block trial. Okay. Well, what about above high block, right? I'm trying to draw a question mark here. What does above high block mean? Okay, well, let's take a look. So above high block means we're going a little bit higher than this high block, okay? So the high block over here, we set up this way, right? And for most of us, we got somewhere around 21 or 22 or 20 centimeters, okay, which is 0.2 or 0.22 meters, right? So we want to go a little bit higher, but not too much higher, because if we get too much higher, then it turns out that the golf ball just kind of hits the desk at an awkward angle, and our time readings are a little bit off because we're not really measuring velocity the way that we think we are, okay? So we want to go a little bit higher, maybe to like right about there, right? And now instead of 20 or 22, we're at like 20, what does that say? 26, okay? That says 26 centimeters, right? So we're at about 26 centimeters, and we can make sure our golf ball's where it's supposed to be, okay? And so that gives us another data point that will allow us to interpolate with our model, okay? So 26 centimeters, that's definitely between 0 and 73 centimeters, or 0 meters and 0.73 meters. So that'll give us good interpolation value, all right? So those are the procedures that you're going to follow today. And just as always, we're collecting we're performing each trial 3 times, okay, 3 times. And it's going to be pretty cool because once you've got your data entered, this table will populate, okay? And I'll go ahead and color this guy. This guy needs to be colored so that you will know not to adjust him. But once you've added your data here and here and here, then this table will auto-populate, okay, and it'll be pretty cool. Except we need to talk about this predicted velocity column that's right here. Okay, so what do we do with this predicted velocity column? So this is the one thing that you actually need to do with this bottom part of your spreadsheet. And for this, you're going to use your formula from last time. Okay, so you came up with a formula from last time, and you're going to plug that formula into that sheet. So my formula says 3.24x to the power of 0.58. Okay, so velocity, which is what I'm trying to predict, equals 3.24 times height to the power of 0.58. So I'm actually going to plug in my formula for you, but you can feel free to overwrite my formula and use your own if you would like to. Okay, that will really allow you to test your mathematical model's predictive ability. Okay, so let me show you how you do that. The first thing you do is that when you click one of these squares, you type equals. And then the first number in our formula was 3.24. Okay, and it's 3.24 times some height value, right? Well, where are we going to get the heights from? We're going to get the heights from here, here, okay, and here. All right, here. So let's go ahead and put those height values in, or sorry, let's go ahead and reference those cells. So this height comes from C. This is column C, and it's row 5, C5, okay, is that cell? So it equals 3.24 times C5 to the power of, okay, it's hard for me to zoom in any further. So let me see if I can zoom in with can I zoom in with my little pincher here? No, I can't. C5 to the power of 0.58, okay? So that's how that works. And let me go back to my formula to double check. Yeah, 0.58 is correct. Okay, and then in this case, it's gonna equal, again, 3.24 times, not C5, but now this is F5, okay? F5, I just click on it and it populates for me. I can also type F5. F5 to the power of 0.58, okay. And now, in this case, we've got equals 3.24 times I5 to the power of 0.58. Okay, so now we've actually got, in this case, we've actually got a predicted velocity value. Okay, we've actually got a predicted velocity value. And eventually we're going to have a percent difference between the predicted velocity and the measured average velocity. Okay, so that's going to be pretty cool. And this percent difference formula has been filled in for you. We'll talk more about percent difference or percent error calculations another time. But for now, you're ready to go, okay? So this table is ready to go with the caveat that I've left these guys white instead of colored, instead of like that pale, like greenish, grayish color, okay? So that if you want to enter your own formula, you can, okay? You can feel free to use your own formula, but my formula is there for you if that process seems complicated. I know we're all still getting used to spreadsheets, okay? So those are your instructions for today. I know you're gonna do a great job. And as always, okay, may all the forces be with you.